All right, today we're going to talk about a few more methods to display data. You guys already learned about a box plot, which is a good way to show the spread of data. And today we're going to talk about frequency tables and histograms. All right, so with this data here, we're going to make a frequency table. So this is one of the questions that you guys answered on that Google form that I sent out. How many siblings do you have? So a frequency table is a great way to collect data because you use tally marks to collect the data, and then you write the actual number of the frequency later, and that prevents you from needing to like scribble out a 1, scribble out a 2, scribble out a 3 every time you collect a new piece of data. Okay, so we're going to use frequency table to collect the tally marks based on the data that you gave me of how many siblings do you have. Normally we'd be doing this in class. I'd have this on the board and I'd go around and I'd ask each of you, how many siblings do you have? And we'd put it up on the board and then we'd count the frequency at the end. So this is a great way if you're out taking a survey of people, or if you have a mess of data like we have here, you can just tally mark as you learn the information. So let's just go across rows like this, across like that. Okay, so we have 3, 1, 0, 2. So I'm going to go into my table. I'm going to put a tally mark at 3, okay, at 1, at 0, and at 2. Okay, and that's how a frequency table works. You write, what are you collecting, the number of siblings. You write some of the options here going down, and it makes sense to have one number for each of these rows instead of having like a range of numbers. And then you're going to put tally marks in the middle column, and then at the end you'll count the frequency. Okay, so we finished that first one. So now we have 1, 2, 2, 0. So 1, 2, 2, 0, 1, 1, 1, 1. Okay, remember when we get to 5, we put a line across to show that that's a group of 5. 1, 2, 3, 1. Okay, 3, 1, 1, 4. 1, 3, 2, 1. Okay, 0 and then 3 1s. 2, 2, 1, 1. 3, 2, 1, 3. 2, 3, 2, 1. 2, 2, 0, 1. 2, 4, 1, 2. 2, 4, 1, 2. 4, 3, 0, 0. 3, 1, 1, 2. 3, 2, 1, 1. 1, 2, 2, 0. 1, 1, 2, 3. Ooh, we have a 7. 1, 2, 0. Okay, and then 1, 2, 0, 1. And 1, 2, 3. Okay, so now that we have our tally marks in there, we're going to just count the frequency. So for 0, we have 9 as our frequency. For 1, we have 5, 10, 15, 20, 25, 30, plus 2 more is 32. For 2, we have 5, 10, 15, 20, and then 2 more is 22. And then for 3, we have 5, 10, and 2 more is 12. For 4, we have 3. For 5, we have 0. For 6, we have 0. And for 7, we have 1. Okay, and it's important to keep that 5 and that 6 there as 0 to show that nobody in the 6th grade that filled out this form at least has 5 or 6 siblings. All right, so if we look at this, we can make some claims about this data. We can say that the majority of people in the 6th grade have less than 4 siblings. Or we can say that they have no more than 3 siblings, or the majority have no more than 3 siblings. We can say that the most number of students have only 1 sibling. We can say that the majority have 1 or 2 siblings. So this just helps us to see, what is the most frequent number of siblings in the 6th grade. Okay, now we're going to create a histogram. So what I've done is I've taken the data from that we collected as a class for how many cards did you pull out before you got the Queen of Hearts from that Google form. And the first thing when you're creating a histogram that you want to do is you want to create a frequency table to help you out. Okay, with a histogram, we're talking about intervals because if we think about the number of cards in a deck, there's 52 playing cards in a deck of cards, but sometimes our decks of cards come with other cards such as jokers or extra cards, and so we need our numbers to at least go up to 52, if not a little bit higher for this because of the extra cards that might be in our deck. Okay, and so we don't want to write out a number for every number from 0 to 52 plus, right? So instead we're going to use intervals, and those intervals are going to represent a range of cards that we're going to collect our data for. So in this case, we're going from 0 up to 52 plus. And so I think that 8 cards would be a good interval to use because that would give us like 9 or so intervals. Okay. So our first interval is actually going to be from 0 to 7. Now, you guys might think it should go up to 8, but if we think about that, that would actually be 9 cards instead of 8 because we start counting at 0. So if we count 0, 1, 2, 3, 4, 5, 6, 7, that is actually 8 cards. Okay, so our intervals are going to go from 0 to 7. Then we're going to go up to one more from 7 to 8 to 15, 16 to 23, 24 to 31, 32 to 39, 40 to 47, 48 to 55. And if you actually look at the first number in our intervals, that's where we see our multiple of 8. So instead of making you guys suffer through watching me tally all of these up, I instead made the frequency table for you, or at least started. Basically, I looked at our data, and every time there was a number from 0 to 7, I put a tally mark in that. So like for this first one, we had 7 as our first number, so I would have put a tally mark in this 0 to 7. 5 would have put another tally mark in the 0 to 7. Okay, so let me just finish filling in these frequencies here, and we have all of our data ready to go. So for a histogram, it's kind of like a bar graph, but instead of having each bar at an individual number or an individual data point, then we're going to have intervals along our x-axis for the number of cards. So our first interval is going to be 0 to 7, and then 8 to 15, then 16 to 23, 24 to 31, 32 to 39, 40 to 47, and 48 to 55. Now, the other thing about histogram is that the bars have to touch because they are intervals. Okay, it's not like individual data points. We're looking at intervals, and so that the touching of the bars kind of shows that the intervals are somewhat arbitrary. Okay, we could have picked an interval of 10 cards or an interval of 5 cards, and that might change the way that our data looks a little bit. So with histograms, it's very easy to manipulate the data, and so you have to be careful when you're looking at a histogram to really see what the intervals are and see if the intervals could be causing the data to be manipulated and manipulated to look a specific way. So for the frequency, we need to go all the way up from 2 to 26. So let's count up by, let's do 5s. All right. So 5, 10, 15, 20, 25, 30. Okay, so from 0 to 7, we need to go up to 26, which is just a little bit above 25. So I'm going to draw a line like that, and then I'm going to draw a bar down. Actually, let's use a different color. We can shade that in a little bit. All right, for 8 to 15, we had 21 cards in there, so we're going to go a little bit above 20 to 21, and see how I'm connecting the bar to the other one, because remember, these are intervals, so our bars need to touch to show that it's kind of a continuum of data. All right, 16 to 23 had 12. 24 to 31 had 6. As did 32 to 39. 40 to 47 had 5. And 48 to 55 had 2. Okay, so a histogram is good at showing us the distribution of the data, okay? In this case, we can see that the majority of people picked through on their deck of cards a relatively small number. A lot of people had less than 15 cards before they pulled out that Queen of Hearts. All right, so we see that this data is what we call skewed to the left, okay, because most of that data is up on the left here, and then our bars are much shorter on the right. Okay, so that's a histogram. Bars that touch, intervals, helps us to see the distribution of the data.